What if I told you that to build this highway in Guizhou Province, China didn't just cut through mountains, they moved them? And what if I told you that the real reason for the project has nothing to do with transportation at all? This is the story of the most dangerous construction site in modern China. And by the end of this video, you'll understand why China spent hundreds of millions carving a route that defied every law of engineering. A province trapped by stone and time. Guizhou Province in southwest China is a place where the land itself feels hostile to human life. For centuries, people here have lived under the pressure of steep mountains and sharp cliffs that seem to rise without end. The ground is uneven almost everywhere, and flat land is very rare. Villages that looked close on a map were often separated by hours or even days of walking. Roads bent sharply around cliffs and narrow ridges, forcing travelers to move slowly and carefully. During the rainy season, the danger grew worse. Heavy rain loosened soil and stone, sending mudslides and falling rocks crashing down without warning. A simple trip to fetch food or tools could turn into a fight for survival. This harsh land created deep isolation. Farmers worked hard, but many lost their crops before they could even reach markets. Produce spoiled during long journeys. Children often stayed home because schools in nearby towns were impossible to reach safely. Families lived within sight of each other across valleys, but could not meet without dangerous climbs. Emergencies became tragedies. In many remote villages, people died because help could not arrive in time. Illness, injury, and childbirth carried terrifying risks. As China changed and modernized, Guizhou remained trapped. Factories, trade, and investment passed it by. The mountains acted like walls. They kept people poor, cut off, and afraid. Residents lived with the knowledge that the outside world was moving forward while they were left behind. Government planners eventually saw what the numbers could not hide. Millions of people were being held back by the land itself. To change life here, the mountains would have to be challenged directly. Rock would need to be cut. Valleys would need to be crossed. Engineers would be pushed into dangerous choices where failure could cost lives. China's radical decision to break the mountains. Faced with Guizhou's impossible terrain, the Chinese government made a decision that shocked engineers around the world. Ordinary roads could not solve the problem. Ordinary bridges could not reach the villages high above the valleys. The government decided on something almost unimaginable. They would build more than 32,000 bridges across the province, each spanning deep gorges, yawning canyons, and cliffs. The first hurdle was disbelief. Engineers looked at the plans and aggressively shook their heads. Could bridges survive the violent winds that tore through the mountains? Could they hold against earthquakes that had shattered villages for centuries? A single miscalculation could destroy the structure entirely. Worse, it could kill hundreds of workers or villagers waiting to cross. Building at such heights was terrifying. Construction crews would work hundreds of meters above the canyon floor, where one slip meant death. Steel towers had to be anchored in rock that was jagged, fractured, and sometimes barely stable. Landslides were common. Sudden storms could wash away scaffolding in minutes. Every day on the job carried a silent, constant threat of disaster. Yet the government refused to accept failure. The bridges were not just structures, they were lifelines. Each one would transform the province, connecting people to hospitals, schools, and markets that had been unreachable for generations. Lives depended on these bridges. Ordinary caution would not be enough. Every bolt, every steel cable, every calculation would be tested by extreme conditions. There could be no mistakes. Among all the construction sites, the location that terrified engineers more than any other was the Huajiang Canyon. The canyon dropped hundreds of meters below jagged cliffs, twisting and deep, with winds that could knock a person off balance and storms that could sweep equipment into the abyss. Building a bridge here was not just difficult, it was almost a battle with nature itself. Engineers knew that every measurement, every anchor, every piece of steel had to be perfect. As the crews prepared to work, fear was palpable. Some looked over the edge and felt their stomachs turn at the sheer drop. Regardless of all doubts, work soon began on the main highway that led to the bridge. Cutting a mountain in half to build a straight road. The highway leading to the Huajiang Bridge, which is part of the Guizhou S57 expressway, faced one overwhelming obstacle. A single massive mountain stood directly in the path of the planned route, rising like an unbreakable wall above the valleys on both sides. Engineers could have taken the safer option and designed the road to curve around it, following steep slopes and cliff edges. But that detour would have increased travel time, wasted enormous resources, and left dozens of nearby villages isolated from critical services. So the Chinese government made a bold decision. Instead of going around the mountain, they would go through it. They would cut the entire mountain in half to keep the highway straight, efficient, and connected. The operation required careful planning and relentless effort. Workers used explosives to break apart solid rock. They operated giant drills that bored deep into the mountain, creating holes for the controlled blasts. Every explosion carried serious risk. If the blast was too small, the mountain would remain unbroken, delaying the project and leaving villagers isolated. If the blast was too strong, it could trigger landslides that would bury workers, destroy machinery, or damage nearby homes. Dust clouds filled the air immediately after every detonation, making it nearly impossible to see or breathe. Villagers lived in constant fear as their houses shook under the vibrations and dust fell like snow over the surrounding valleys. Thousands of tons of rock were removed over months of exhausting labor. The workers endured unbearable conditions. The noise of explosions, the constant shaking of the ground, and the choking dust made every day a struggle to survive. Injuries occurred frequently, and some workers were crushed by falling rock, cut by heavy machinery, or knocked off balance on unstable slopes. Some workers did not survive. Others suffered permanent injuries or long-term respiratory illnesses caused by inhaling the dust. Engineers and supervisors spent long hours examining the remaining rock for cracks or weaknesses that could signal an imminent collapse. Even the smallest miscalculation could trigger a disaster that would destroy weeks or months of work and claim lives. Despite the constant danger, the workers continued their mission. Day after day, the mountain slowly yielded to human effort. Eventually, the rock split to form a V-shaped gap, wide enough for the highway to pass straight through. Beyond the split mountain, the project now prepared for its most ambitious challenge, which was building a bridge across the Huajiang Canyon, a task that would demand even greater courage and confront workers with daily threats to their lives. Building a bridge without touching the ground. The Huajiang Bridge was built without using the ground for support at any point. Workers could not place scaffolding on the canyon floor because it was too deep and too dangerous. Temporary support towers were impossible. There was no safe foundation. This meant the entire bridge had to be built while hanging in the air. Gravity was always pulling every piece downward, and engineers had to fight that force during every single step. From the first steel piece to the last connection, the bridge had to hold up its own heavy weight the whole time. The steel frame of the bridge weighed about 22,000 tons. This is more than 3 times heavier than the Eiffel Tower. All of this weight was hanging over a huge open space. The balance of the steel pieces had to be perfect at all times. If one piece tilted the wrong way, the force would spread across the whole structure. A small mistake could cause a very big problem. Once a piece was put in place, they could not remove it or fix it easily. Normal cranes were also immediately ruled out. The canyon was far too deep for a crane to stay stable. Strong winds at the top of the canyon made crane arms shake, which would make lifting dangerous. Besides, no crane in the world could safely lift 100-ton steel sections to this height and keep them still. So the engineers did something crazy. They created an entirely new lifting system that did not touch the ground at all. They stretched thick steel cables across the canyon, forming a pathway in the sky. These cables were held in place by massive anchors on both sides of the cliff. Small motorized machines, shaped like simple rolling carts, moved along the cables and carried each steel section through the air. This method looked insane, but it was the only way to move such massive pieces without touching the canyon floor. It also turned the sky itself into the job site, which made the work even more dangerous. Every piece had to be moved inch by inch, and everyone involved understood that one sudden gust of wind could end the entire project in seconds. Wind was one of the biggest threats. Storms brought winds strong enough to damage the cables or break pieces apart. Fog often covered the entire canyon, which made it difficult to see. When this happened, workers relied only on instruments. They used satellite guidance and real-time GPS tools to place each steel section in the exact correct spot. These tools helped them measure every movement very precisely. Sensors placed around the bridge watched for any sign of stress or bending. If the sensors showed something unsafe, the work stopped right away. The process was slow and very demanding. Each steel section took several days to move and install. Sometimes a section had to hang in the air for many hours while workers waited for the wind to calm down. The workers also had limits. Being at such extreme heights made their bodies react with fear and dizziness. Their vision sometimes became less sharp. They had to work in short shifts to avoid getting too tired. Even after the last steel section was hanging in place, the hardest and most delicate step was still ahead. So how did the engineers pull the two sides together, connect the final pieces, and turn the hanging structure into a complete and stable bridge? How the bridge was actually built. The first major task in building the Huajiang Bridge was installing the two main suspension cables. These cables are the parts of the bridge that carry almost all the weight. To install them, workers first pulled small guide wires across the canyon using drones and boats. These small wires were used to pull larger and stronger cables across. Each stage used a thicker cable until the final suspension cables were in place. Once the main cables were ready, workers locked them into giant anchor blocks carved deep into the rock on both sides of the canyon. These anchors held the entire bridge. Without them, nothing else could happen. Next, the engineers anchored the aerial cable crane system. This system used very thick cables stretched across the canyon. Each cable was held in place by steel towers and heavy anchor points. Workers tightened the cables until they had the exact tension needed to stay firm. They checked the tension many times because even a small mistake could make the lifting system unsafe. Once the cables were ready, motorized carts were attached to them. These carts acted like moving platforms in the sky. Now the heavy lifting began. Each steel segment of the bridge weighed around 100 tons. Workers connected the steel sections to the cable carts on one side of the canyon. The carts then carried each section across the open space. The movement was very slow. The carts could not move fast because fast movement would cause the steel to swing like a giant pendulum. Workers watched every inch of travel. If the wind changed direction or became too strong, they stopped the lift until conditions were safe again. When the steel section arrived at the center area where the bridge was growing, workers used ropes, small guide cables, and alignment tools to position it. They were standing on narrow platforms attached to the already completed parts of the bridge. At that height, the wind was strong and unpredictable. Workers had to use safety harnesses at all times. They connected each new piece to the existing truss by using large steel plates and thick bolts. Each bolt had to be tightened in a specific order so the weight would spread evenly across the structure. As the bridge grew outward from the center, the structure needed to stay balanced. If one side became heavier than the other, the bridge could twist. To prevent this, engineers always installed pieces on both sides in pairs. They placed one section on the left side and then placed the same section on the right side. This kept the forces equal and the bridge stable. Sensors were placed along the steel to measure bending, twisting, and tension. If a reading became unsafe, workers stopped immediately to make adjustments. The next major challenge was the midpoint closure. This is the moment when the two growing ends of the bridge meet in the middle. This moment is extremely important because if the alignment is even slightly off, the two halves will not connect. Before closing the gap, engineers measured the position of each side using laser tools and GPS. They had to make sure the height, angle, and length were exactly correct. When the time came, they used the cable carts to lift the final closure piece. Workers guided the piece slowly between the two ends. The bridge did move a little because steel bends under weight. This bending was expected, but workers watched closely to control it. When the piece was in the right spot, workers used large iron pins to lock it temporarily. Then they installed the final bolts. Once the closing section was secure, the bridge finally became one connected structure. After the closure, the weight of the bridge had to be transferred fully to the main suspension cables. Workers tightened the hangers, which are the vertical cables that connect the roadway to the main cables. This step made the main cables carry most of the load. Workers measured the force in each hanger and adjusted them to make sure the weight was balanced. The final lift and alignment process came next. Workers checked the straightness of the roadway, the height of the deck, and the angle of the trusses. If something was slightly off, they used small jacking devices to lift or lower sections by a few millimeters until everything matched the design exactly. This required patience because moving one section could affect the others. Before the bridge opened, engineers performed a full stability check. They tested for vibration, temperature changes, wind behavior, and load distribution. They placed weights on the bridge to see how it reacted. They checked the sensors to confirm the structure stayed stable under stress. Only after every test showed safe results did they approve the bridge for public use. This was the moment the impossible became real. The final steel section was in place. But once this piece was locked in and the bridge stood on its own, the work was far from over. Building the structure was only the first challenge. Keeping it safe in a place filled with constant danger became the next and even more difficult task. Fighting structural stress. The Huajiang Bridge stands above a deep canyon in an area where the ground moves often. The two main towers are not the same height. The North Tower rises 262 meters, while the South Tower reaches 205 meters. This difference makes the bridge react in a very unstable way when the earth shakes. When even a small earthquake hits the region, the tall tower and the shorter tower move at different speeds. This uneven movement sends strong waves through every cable and steel beam. The motion can spread from one side of the bridge to the other like a shock traveling through a metal chain. To reduce this force, engineers installed large shock absorbers inside the structure. These devices act like the suspension of a car. They soften the shaking so the steel does not break. Even with these protections, the bridge still moves when the ground moves. It bends slightly. It sways. It makes deep, heavy sounds that remind workers how powerful the earth can be. During construction, engineers also built fiber optic sensors inside the cables. These sensors measure tension, stretching, bending, and vibration every second of every day. The readings travel to a control room where a team of engineers watches them on screens. The team works day and night. They look for sudden changes that could show a problem. If a reading rises too fast or drops too low, the system alerts them. They respond immediately because one missed warning could lead to a serious threat to the structure. Wind is another major problem. The canyon works like a funnel that squeezes air into fast and violent gusts. Some gusts move as fast as a high-speed train. These winds can twist the cables and push hard against the steel deck. A strong enough gust could loosen bolts or put too much pressure on one side of the bridge. Engineers use a Doppler LiDAR system to study the wind. This system sends out invisible beams that measure how the air moves. It creates a three-dimensional map of the wind, so engineers can predict its direction and strength before it becomes dangerous. Even with this system, the wind still creates risk. It changes quickly. It can strike from a new direction without warning. A few minutes of calm can suddenly turn into a burst of violent motion. Trucks that cross the bridge must be careful, especially when they carry heavy loads. Maintenance workers also take great caution when walking along the deck because a sudden gust can knock a person off balance. Despite these constant threats, the bridge continues to stand strong. Its cables hold firm. Its steel remains secure. It survives because engineers watch it closely, repair it when needed, and treat every day as a new challenge. The bridge stands proud because the people who maintain it never stop paying attention. And once engineers learned how to protect the Huajiang Bridge from earthquakes, wind, and constant stress, a different question came next. Why build something so difficult in the first place? And what could possibly justify the risk and cost? What this bridge gives to Guizhou. Huajiang Bridge cost more than $300 million and took more than 3 years to finish. But its value is far greater than the price. For people in Guizhou, it connects communities that were cut off for generations. Villages that once felt unreachable now link to major cities in minutes. Businesses can move goods across the region in a straight line instead of crawling through dangerous mountain roads. Transport companies save millions each year because the direct route cuts fuel use, travel time, and mechanical wear on vehicles. The bridge also acts as a backbone for new development. Areas near the canyon now have better access to clean water projects, power lines, and internet cables. New housing, restaurants, and small hotels have appeared. Huajiang Bridge also strengthens China's national transportation network. It links to the Guizhou S57 expressway, which then connects to major trade routes across the southwest. This makes the movement of goods across provinces faster and smoother. It helps nearby industrial zones reach ports and airports. It also supports the long-term plan to improve the economic strength of Western China, making it easier for the region to compete with coastal cities. Tourism adds another layer of benefit. One of the biggest attractions is the glass elevator built beside the Huajiang Bridge. This elevator is attached to the side of the cliff, and it moves straight down into the canyon through a transparent shaft. The walls and floor of the elevator are made of strong layered glass that can hold several tons of weight. Visitors can see everything around them as they descend: the steep rock walls, the flowing river below, and the entire span of the bridge above them. The elevator operates with a simple but powerful system of steel cables and electric motors that keep the ride smooth. Safety sensors watch the movement of the elevator at all times so that it never moves too fast or stops suddenly. The elevator gives visitors a rare experience. As it moves downward, the bridge slowly rises above them until it hangs directly overhead. People can see the main cables, the steel beams, and the enormous height from a viewpoint that is normally impossible. When the elevator reaches the canyon floor, visitors step into a quiet world far below the roadway. They can walk along marked paths, stand under the bridge, and look straight up at the massive structure. The glass walkway is another major attraction, but it is also the part that frightens visitors the most. It hangs from the side of the cliff and allows people to stand directly above open air, hundreds of meters above the canyon floor. The walkway is made of thick, reinforced glass panels supported by heavy steel frames. Every panel is engineered to handle extreme weight, strong winds, and sudden movement. From a technical standpoint, it is completely safe. Emotionally, it is overwhelming. As soon as people step onto the glass, many freeze in place. Their legs begin to tremble uncontrollably as their brains struggle to accept what their eyes are seeing. The transparent floor makes the canyon feel closer than it really is, and the depth is so extreme that some visitors instinctively drop to their knees. Others grip the handrails tightly, crying or laughing in panic as their bodies react before their minds can catch up. Some visitors cannot move at all. Staff members are trained to help people who panic halfway across. There have been cases where tourists burst into tears, hyperventilate, or have to be guided back step by step. A few have even passed out from fear after looking straight down through the glass. The sensation is not just height but exposure. For many, crossing the glass walkway becomes a personal battle. Those who make it across often describe it as one of the most terrifying experiences of their lives. And some absolutely enjoy every bit of it. These attractions bring money into towns that once struggled. Restaurants, tour guides, and small shops now thrive because visitors stay longer, explore more, and spend more. The bridge, the elevator, and the walkway work together to turn a remote canyon into a busy and successful tourism center. Make sure to click the cards on the screen now for more interesting videos.